Hello, my dear students. I hope you are doing great. So let's do this question from kinematics, projectile motion. I have put this question in practice problem in JEE Advanced section in physicsma.com. So let's see this question. A frog wants to jump over a fixed cylindrical log of radius capital R resting on a horizontal ground. The frog jumps from the ground, clears the cylinder without touching it, and lands on the ground on the other side. Assuming the frog grazes the cylinder tangentially at 2 points. What is the mean speed, right? Minimum initial speed, you mean, with which the frog must jump. So here is the diagram you can see. In this diagram, this is a cylinder and there is a frog over here. And this frog wants to jump so that it just touches at 2 points P and Q. This point is P and this point is Q. At these 2 points, it's going to touch the cylinder. It just grazes, right? So I can say that now after this grazing, it lands back here. So we have to find what is the minimum U for which such condition can happen. Okay. So how to solve this problem? Let's do this step by step. First, let's see the geometry of this one. So if we see the geometry, so this distance is PQ, right? And this angle I have taken as beta. This is your beta angle. And this radius is R. So obviously I want to find this PQ length. PQ length will be, this is R. This is going to be R sine beta. Half of this is R sine beta. And this is also R sine beta. So PQ length is going to be 2R sine beta, right? And the vertical height of this level from the ground, if you see, this distance is going to be, this is radius R plus this is going to be, this one is your R cos beta, right? Because this angle is beta. So it's going to be R cos beta. So R plus R cos beta. Later on, we are going to make use of it. So what are the steps here? The first of all, we have to see the trajectory geometry. But this is the geometry which I have said. This is 2R sine beta, right? And this angle is, by the way, beta as well. So we saw the trajectory geometry. Then again, what we have to do, somehow we have to relate this velocity V, this velocity V at P, velocity at point P, with beta. How you can relate that? If you are able to relate it, then we can move on to the next step. We will discuss about the next step. So how to do that? Somehow you can think of the time of light, right? So here, if you see this, this is your V cos beta in this direction and V sine beta in vertical direction, right? So this is your V sine beta in vertical direction. And from P to Q, what is the time taken? We know 2 Vy upon G, right? Vertical component by G. So this is 2 Vy by G, which is nothing but 2 V sine beta by G, right? So this is your step number 2. And then we can also have this PQ. PQ, this distance PQ is going to be covered with V cos beta, right? So time we have already found. So what is your time? Time is 2 V sine beta by G. And this PQ distance is going to be velocity in x direction, V cos beta times the time. Time taken is 2V sine beta by G, right? So this twice, this together is equal to 2R sine beta. 2R sine beta is PQ. So somehow we have related this to the, the geometry, right? So from here, we can get this value of V squared. V squared value is GR sine beta. Somehow we wanted to relate V in terms of beta, which we got. And then the next step we are going to do is the conservation of energy, right? And as I have said, this distance is going to be R plus R cos beta, right? From the ground, the distance is going to be R plus R cos beta. So write down the conservation of energy. Initial energy is half mu square on the ground. And then here at point P, what is the velocity? V. So half mv square kinetic energy plus the potential energy is mgh. Hp is the R plus R cos beta, right? So from here, you will be getting U square is equal to V square plus 2G into R plus R cos betas. Simplify that. So U square you are getting is equal to GR into 2 plus sec beta plus 2 cos beta, right? Then we have to find the minimum value of U, right? How to do that? How to find this minimum value of U? V square we have substituted from there. V square is GR sec beta, you have substituted. And then U as a function of beta you got. And you have to minimize. So one way is, okay, in order to find U mean, apply maximum minimum like du square by d beta equal to 0. Other way around, this is one way. Other way around is Directly we can apply AMGM concept, right? This is very handy result to find the minimum value. In mathematics, in algebra, you have already studied, right? The arithmetic mean is going to be greater than equal to the geometric mean. So I'm checking the sec beta and 2 cos beta as two numbers. So the arithmetic mean of these two numbers, sec beta plus 2 cos beta by 2, greater than equal to the geometric mean, which is sec beta into 2 cos beta square root, right? And from here, we are going to get sec beta cos beta is 1, right? So we are getting greater than equal to root 2. So we are getting finally sec beta plus 2 cos beta is greater than equal to 2 root 2. That's it. And then put back here and you will be getting u minimum squared. U minimum squared is gr into 2 plus minimum of this, which is 2 root 2. So minimum u is equal to square root of 2 gr into root 2 plus 1. And that's the answer. I hope you got it pretty well.